Hi everybody, and welcome back to this tutorial on building a Linux from scratch system. Now in the last video we've talked about the big picture of the whole process and now we'll start actually doing all that. But before we start we need to talk about some requirements. So I have a new laptop, as you can see, and I'm running a Manjaro Linux on it with a Linux kernel 5.10. And yeah, for the whole process, the Linux from scratch tells you to install, of course, some packages. So I would need to install bash. Well, if you have a Linux system, you probably have a bash, but okay, then bin utils, bison, bzip, core utils. Well, you probably have core utils also, because without core utils you can hardly do anything in a Linux system. Diff utils, find utils, GNU org, gcc, a glibc. You probably have a glibc also. Grep is also usually there on a Linux system. Gzip, well, a Linux kernel. M4, make, patch, Perl, Python, set, the stream editor, tar, text info, and xz. Okay, yeah, as you can see, I've already installed all of them. Okay, it's complaining about bzip. That package is named bzip2. Okay, now I have created a new user here named LFS. And yeah, so I have created this directory here now, LFS programming LFS. And I will start writing some scripts here. Because I want this whole process to be repeatable. You know, if anything goes wrong, I want to be able to just delete everything and run the script from the start, and I want that to resolve all problems up to that point. So I'm gonna call this lfs.sh, and I will open that with Kate again. Still a great text editor, still using that a lot. Yeah, so the first thing that we will be doing, as I said, is going to be yeah, formatting the USB key and creating the partitions. So I'm going to make a script setup disk.sh, and I will have a script version check.sh, and yeah, I will also already create a script download.sh. Okay. So yeah, as I told you, I've created a new user especially for this whole process. The Linux from Scratch project advises you to do that, but it's not strictly necessary. So yeah, I'm not gonna do that as part of this video. So yes. Okay, so in this lfs.sh, we will have our usual shebang. And the first thing that you really should do, and everybody's going to tell you that, you really should define a variable lfs and set that to your mount point. Okay. And since we might be running stuff in subshells, I will also export this variable. And another variable lfs underscore tgt for target. And yeah, we will set that to x86 underscore 64. So we are going to build a 64-bit Linux here. LFS Linux GNU. So this is a classic triplet that you would pass to compilers to tell, or to other systems to tell them, yeah, I want something for a 64-bit processor, something that will run in a Linux system, in particular a Linux system from this vendor. Okay, LFS is not so widely used, so your compiler will probably not have any special code for that vendor, but okay. And GNU here, that's the name of the application binary interface. Yeah, on other machines this might be something different, like GNU EABI would be something that you might see on a Raspberry Pi, for example. Okay, and I will have a variable lfs disk, and I will set that to def. Okay, I don't know the name of the device yet, so I'm gonna plug it in. Okay, and now I'm gonna do sudo desc to look for the device name, and okay, it's telling me here that the device that I have just attached has gotten the name SDB, so I will put SDB here. Good. Yeah, so let's start going into the setup of the USB key. But I don't want to format the disk all the time, you know. I just want to do it once and then mount it and work on it, because yeah, I mean the sizes of the partitions don't need to be changed all the time. When we've downloaded the tarballs, I don't want them to be downloaded again and again, which I mean, we store them on the USB key, so if we formatted it all the time, we would always have to re-download all the packages, and I want to avoid that because I don't want to cause traffic on these servers for no reason. So I will just check here if the disk is mounted. So this file proc mounts, that file tells you which systems are mounted on your system, right? So yeah, so you can just use that virtual file here to see, is something already mounted on our LFS mount point, and if it isn't, that's this exclamation point here, if nothing is mounted there, only then will we execute our script. And I think it's a good idea in this context to do it not explicitly, but by sourcing the files. Okay. And just having the destination as a parameter here. Okay. So how do we set up the disk now? There's this program Fdisk. It's not exactly user-friendly, I have to tell you that. But it works on the command line, and that's why I think it's a good idea to use it here. So now this LFS disk is passed to us. I mean, it's actually not necessary. If we source this, then we should inherit these variables here, but and since they are exported, we should inherit them anyways, but yeah, I will just source the sub scripts, and yeah, as I said, I will still pass this as a parameter, and then I will just take it here as a parameter. Okay. And yeah, well, what do we how now we need to control Fdisk. And Fdisk is a bit you really need to know what you're doing there. So let me just show you. Okay, so this Fdisk takes commands in such a query and response manner. So the command M shows you the help, as I told you. Then you have these different commands that you can give it. But this is really not very user-friendly when you are automating that stuff in a script. So so here we have the command to create a new partition table. So this here is a so-called here input. So I will just have the inputs to this program right here in the script. And yeah, as I said, O is going to create a new partition table. Then N creates a new partition on that disk, so I will put an N here. And okay, I mean, actually I can do this while I'm showing you this. So O creates a new partition table, N creates a new partition. Now I have to select what kind of partition, a primary or an extended one. I will take a primary partition. So by using a P here, the partition number is going to be partition number 1. So I will put that here also. Where should it start? Well, I will just not enter anything. I will just press return here, which means it will use the default, so it will just start at the beginning of the disk. Here in the script, I will repeat that by just an empty line. Then it asks me, okay, how large is that partition going to be? I will just say plus 100 M, so it's going to be 100 megabytes. Okay, it's warning me. I've used this USB stick before, so there is already a partition table and a file system on it, but I'm going to delete them, so I will just ignore this warning here. Where was I? Ah, yeah, plus 100 M. And I will yeah, with an A I can make it bootable. Okay, now it's bootable. And now I will create another partition, basically the same steps as before. N for a new partition, primary partition, partition number 2. Again, default is just put it right behind the first partition. Now for the second one, I will also not input anything, which then means it will just use the whole disk. Okay, ignore this warning again. So what I just did, I will repeat it here. New partition, primary partition, partition number 2, starting directly behind partition 1 and going to the end of the disk. Okay. And then when I'm done, I will just print the partition table with a P. And then I will write that to the disk and close the program with a Q for quit. Okay. As I told you, this is not really pretty here, but it gets the job done, and I have actually seen ways to pipe this stuff through a set command and then you could also have some comments here like new partition, but for simplicity I will omit that here. Okay, so this all looks good. Okay, so let's see if this setup disk sh works as a works on its own. So we haven't mounted anything, so this check should run through, and then it should execute that setup disk sh. So let's do that. I will make the main lfs.sh executable. So yeah, let's run this. Okay. And this looks pretty good. So it created a new partition. A new partition table, a new partition. This is pretty much the output that we've seen before. Okay, it's created a new partition with size 100 megabytes. And one of size 29 gigabytes. Here it's printed the partition table, and yeah, so it looks like it's written its changes and it's stopped. Okay, so this looks good. Looks like the setup disk sh just works beautifully. Okay, so after we've had these partitions, we will need file systems on these partitions. So make file system of type ext2, and we will put them on $lfs disk one. So LFS disk is def SDB, and now that we've created partitions, there's going to be def SDB1 and def SDB2, which are the two partitions. So like this, I put an ext2 file system on the first partition and on the second partition. Okay. Yeah, that looks pretty good. I will just run it again. But wait, I will, after I've created that, I will already mount it. So this looks good. One thing I will do here now also is I changed the owner to myself. In the LFS book, they create a few directories and then change the owner of all these directories to the LFS user. I'm changing the owner of the whole mount point to myself, because, well, if I delete directories, I want this to require root privileges. So if I reformat the whole USB key, that's gonna require root privileges, but whenever I keep using it, if I don't execute this, then I want to be able to run this without root privileges. And in particular, if I delete stuff, then rerunning the script is supposed to recreate that stuff. So because of that, I want to be able to create the directories without sudo here. And yeah, like this. Okay, so in the book this would have required root privileges because they don't set the owner of the whole mount point to the LFS user. Yeah, as I said, I want to recreate all the stuff without root privileges here. That's why I set the owner for everything before doing all that. Okay, so now I will just create a few directories. Tools. This is where this intermediate cross compiler for compiling A to B is gonna sit. Then what else do we need? I don't think we need a boot directory yet, but okay. Let's see. Bin lib. Okay. Okay, so these two directories up here, sources and tools, they are for the Linux from Scratch system. So we will download our tarballs into the sources directory, and yeah, this preliminary cross compiler is gonna sit in tools, and yeah, then this stuff here is just normal Linux stuff, or FSH stuff to be more precise. FSH is the file system hierarchy, which is a standard on Unix systems, which of course we are trying to follow here. Okay, tools boot. Etc bin lib sbin user var sources. Okay, one thing in the LFS book, they often do stuff where they echo the LFS target and check if that's a 64. If we are compiling to a 64 system. So if we are compiling to 64, then we will also have a lib64 directory. Okay. I mean, pretty much everything is 64 bits today, so it's kind of pointless to even check this. And actually, they do it a bit differently here. So this is the way that they do it in the Linux from Scratch book. This is a shorthand for creating all the directories with just one line. I wanted this to be a bit more explicit here, so that's why I did it this way. And they check the name of the processor, so uname-m just gives you the information about your processor. I'm not certain that this really makes sense, because this is your processor of your machine A, but you are building a system here for machine B. So I don't really think it makes sense to check uname-m instead of lfstgt, but I'm not sure. Maybe they check lfstgt later for the. I mean, we are building a cross toolchain that will still run on A. So so for this part, I think it is still arguable to do it the way they did it. Yeah, you know what? I will just do it the way they did it because, as I said, because yeah, as I said, this cross compiler from A to B still runs on A, so I think it's just arguable to do it this way. Yes. Okay. Now, when we have done all this, so far we haven't mounted the directory, right? So we've just set up the disk, and I will just do it one more time. Okay. Oh. Okay, these need to be capital Fs. Okay, run it again. So now it's formatting. This takes quite a few seconds, so that's another reason why I don't want to format it again and again all the time. Okay, so let's see. Oh wait, I forgot something here. We need to put an A here to mark the partition active, because if we don't do that, this sets a flag for the in the partition table, and well, the mainboard will look at this flag, and if it's not set, then that flag means this isn't even a bootable partition, so the mainboard wouldn't even try to boot from it, and so that's where we need to put it there. By the way, remember we've deleted the old partition table, created one new partition, and now we are saying active, or activate. And well, at this point there is only one partition that it could set active, so Fdisk will accept that. But if there were multiple choices like this, if I tried this down here, then Fdisk would say, wait, you want to activate something, but I don't know which of these partitions. So it would then ask you, which partition do you want to activate? And since the partition up here, you know, with the 100 megabytes, that's supposed to be our boot partition, and that has partition number 1. So then we would have to put a 1 in the next line here. But I will put the A up here, and then that should work. So we need to run this again so that the partition is then marked active. So I've run this before, and then the script has mounted the partition. So when it's mounted, then the whole partitioning is skipped in the next run. So because of that, I will have to unmount it again. And now we can run it, the script again. Okay. Okay, so this took a bit longer than I expected. I guess the USB key ran a bit hot or something. But okay, now we've created a new partition. A primary one, number 1. The second one, the first one is bootable. So it now looks like this, 100 megabyte, and the rest bootable, SDB1, SDB2. They're formatted. This is for mounting. And then the owner was changed and the directories were created. So let's look at the directory now. So let's look into /mnt lfs. Okay, so there is our structure. So we have our bin, boot, etc, lib, lib64, sbin, sources, tools, user, and var. These are the directories that we've created here. The disk is formatted and mounted. We've created the directories, and now we can start installing stuff. Okay. So yeah, I think the directory is now, or the USB key is now set up nicely. So I think the next thing we can now do is go through the packages and download them. But that's gonna be in the next video. So yeah, tune in next time. And yeah, if you like this video, like it, share it, subscribe, and maybe turn your ad blocker off. That would help me a lot. And yeah, see you next time. Bye.